Okay. Um, so looking at last night's homework, there it is. Number one was one of the first ones, but I looked at it, a lot of things, there are possible misses, not a big concept. Again, the multiple choices are not too bad. Anything that I need to go over, clean up those that lesson. What was it? What did we do? I don't remember what we did. What we did? Oh, category. Was that category numerical? Or was that 2 days ago? That was 2 days. Jiminy Christmas. Frequency, relative frequency, bar chart. Oh yeah. Bar charts and pie charts. Easy peasy lemon stuff. Good. Today, here we go. So today we're going to be displaying and describing quantitative data. Okay, so not too big of a deal. Displaying and describing quantitative data. 1C today. Monday is 1D. Tuesday is 1D. We may try to get some of 1E in on Wednesday. Friday is 1E, or finish up and review, and then your test is the next Monday. Okay, just kind of keep all that in perspective. Yeah, achieve, and then what I'll give you worksheet wise if I can find some stuff. Yes. I think I'll have a handout or two. So we're going to make and interpret dot plots. So we've talked about dot plots already in this class. So we're going to talk about those just to make sure you're doing them right. And shape of a graph, this is a big deal. This is one of the big deals. You got to understand the shape of a graph, and you got to be able to explain it pretty close. Describe a distribution, and I told you guys, be willing to bet a lot of whatever. That's a question on the AP exam. Describe the distribution. Okay, so when you describe the distribution, you got to know if it's categorical, if it's numerical. If it's categorical, you already know how to describe that. High, low, something else in context. And then we're going to talk about the numerical today. Okay. Make and interpret stem and leaf plots. So we're going to look at dot plots and stem and leaf plots, shape. And then we're going to look at histograms. Okay. So that's what our goal is going to be today. So let's first talk about dot plots, right? On Monday, we talked about categorical, and we used bar graphs or bar charts and pie charts or pie graphs, right? You won't have to make one. You just got to know how to read them. Got to know what's coming, what information is projecting, right? In this section, we're going to learn how to make and interpret several types of graphs that can be used to display it. So one of them we're going to use is a dot plot. That's the first one we'll talk about. We'll talk about stem and leaf plots, and we'll talk about histograms. Those are not the only ones. Okay, so we'll talk about some other ones in 1D and 1E. Okay, so dot plots. We've made them already. Horizontal line, and you're putting a dot with each value. They don't have to start at 0. Right, they don't have to start at 0, but whatever number they start with and whatever the number of the next one is, the next one better be equidistant. We've got to have equal intervals. Okay. Quantitative data, dot plot. Better off with a picture than you are with words of a definition, right? But as long as you know what a dot plot is, you're good. You just got to know what it is. We did a dot plot with the G's, right? The bad products. I started making a dot. I didn't finish it, but I made a couple dot. Put 4 or 5 or 6 dots up there. We did a dot plot with the smelling shirts, right? You guys put a sticker up on the board up there and made a dot plot with that. Those are dot plots. Just each dot represents some value, okay? Represents some value. Everybody here? Man, that's rare. Dot plot is the simplest graph for displaying it. It's one of the easiest ways to display it. So that's one thing you need to understand about dot plots. It's pretty easy to do, but it should be used for small sets of data, right? If you have data set that's like 300, you don't want to put dots up there. You don't want to put 300 dots. It would take way too long to do that kind of stuff. So small sets of data, 30, maybe 50, starting to push it, right? It's fairly easy to make a dot plot by hand. That's why we made a dot plot for those other two. It's pretty easy to do. doesn't require a whole lot of work. You can do it as you go. You don't have to do it. You don't have to have all the information and convert it over. You can do it as you go. Dot plots. I don't see a whole lot of pencils. I don't know how much you need to write on that. Y'all good? Everybody okay? James Bond, a fictional British spy created by the novelist Ian Fleming. James Bond characters made his way into movie theaters since 1962 release of Dr. No. Here are several links in minutes of the 27 Bond movies released. Yay. Make a dot plot of these data. Boo. So we're going to draw a horizontal line. Best we can. Length, movies, James Bond, whatever. Right, we got to put a title down there. Smallest number up there looks like it's 106, 110, 106. I'm going to start at 105. Start with whatever you want. You can start with 106 if you want to. I'm going to start with 105, and I'm going to go by fives. 10, 15, 20, 25, 30, 35, 40, 45, 50. I got to get all the way to 60, don't I? I got to get to 65. Whatever. Y'all okay? Good. 110 is a dot. 106 is a dot. Right? And you're just going to put those dots, and you're not going to have to do this on the AP exam because it does not test anything about your AP knowledge. It doesn't. It might give you one and say what's missing. It might give you one and say what's wrong with this graph. It might give you one and say what number would you start with. I don't think it would even do that, but it's not going to have you make one. Everybody okay with dot plot? Here it is. Boom, boom. That's what it looks like. I would not expect you guys to spend all your time to do that. Homework's not going to make you do that. One of your homework questions, last night was make a bar graph and then decide which one's the highest. And I hope you guys just looked at the data and you didn't actually make the bar graph. But if you made the bar graph, good. But you're not going to have to do it on a test. Everybody okay? Good? Got to know how to interpret. Got to know how to read it. Got to know what it says. Remember that each dot represents one length or the length of one James Bond movie in minutes. That could be a question, right? What does one dot represent? Or what does a dot at 1:15 represent? One single James Bond movie that lasts 115 minutes. I want to say 1 hour and 15 minutes if this is wrong. Questions? Yay, yay, yay. Anything? Anything? Pencils? They're good. They're pretty still. I don't know what else to talk about dot plot. Y'all are really trying to figure out why this class is hard, aren't you? Think about, there's a regular stats class. How about that? You know what the difference between the regular stats and the AP stats? They're making the dot plot and coloring. I'm kidding. I think they are coloring. Here's a good question. They're not getting this question. Any movie that lasts more than 2 hours is considered long by many viewers. This guy. If it's over 2 hours, I'm not going to a movie theater. Can we use the graph in Part A to justify the claim that more than 75% of the James Bond movies are long by this criteria? How many movies are there? 27. They're going to do that a lot. They'll tell you what it is. You don't have to count all the dots. You don't have to count all those. They'll tell you. So I want them what? Longer than 2 hours. And 2 hours is 120 minutes. Fair enough? And so you can do one of two things. You can count all of those dots, or you can count these dots. And I'd probably count these dots because there's less of them. 1, 2, 3, 4, 5, 6, 7 of them, including the 120. It has supposed to last over 120. So there's 7 of them that last 120. That must mean that what? If there's 27 of them, then there are 20 over 120, right? So 20 over 120 out of 27. Who's got a button? I don't know what that is. 74%? Sure? You did a calculator? Ooh, close. 74 what? 749, we get real close. Can we use the graph? We can use the graph to justify the claim that more than 75% of the James Bond movies last longer? No. We can use the graph, but we can't justify that over 75%. And so your answer is no. And if you just put no, you're not going to get it. That answers this part. You need to explain your answer. Because there are 20 dots above out of the 27. And 20 out of 27 is 74%, not 75%. Okay? This is where we're going to get to write whatever you feel like you need to write in order to get the points. But don't write so much that you end up writing something wrong. If you write all this, I'm going to be unhappy, but you're going to get all the points. From the dot plot, we see that 7 of the, they actually did it the way we did it, are shorter than, thus 20 or greater than, which is 74.1%. Because 74.1% is less than 75%, the dot plot cannot be used to justify the claim. It can be used, it just can't justify the claim. More than 75% lasts longer than 2 hours. What do you think? Yes, no? Not too terribly difficult? The writing is a little bit more difficult, making sure you're writing enough to get your points, but not writing too much to where you're lying. Click. Click. Note, you can make a dot. Oh, they say this. I've never seen one. Oh, I'm an idiot. Sorry. Sorry. I'm an idiot. Gosh, I'm an idiot. I babysit dogs. That's what I do on the side. They drop their dog off and I babysit it. Well, they want to come pick it up. And I can't send numbers because they get very mad. So I sent a number, but I sent them my number. I didn't send them my wife's number. I'm an idiot. Do I know my wife's number? Right now, I only do one. Frankie. Frankie's been my favorite. I've had a bunch though. I started about 2 years ago. When my dog died, I started doing it. I don't get a new dog because I don't have kids at the house anymore. I like to go on vacations. I just babysit dogs. They come and drop them off, and I get to keep them. Get to keep them for a couple of days. Yeah. Then they come back and pick them up. Some of them. Most of them, no. I got rules. I got bit last week, though. Yes. That wasn't a good day. Okay. Did I fix that? What did I actually? I was talking to y'all. I don't remember what I sent. Oh. Okay. Yeah. I just said wrong number. Oh well. She'll get over it. This one's Bo. Is this one? Bo is 7 years old. Beau. It's a labradoodle, miniature labradoodle. Boy, Bo. White. He just showed up yesterday and leaving today. I didn't get to see him very much. Okay, it says this. Sorry, back on task. Yeah, you're welcome. Start throwing things at the teacher. What the heck? It says you can make a bar chart, a dot plot by placing the dot to the right of the location on a vertical axis. I don't think I've ever seen one, but it says that it's okay to do a vertical axis and put the dots out this way. Like I said, I've never seen one. You can use dot plot or other graphs to quantitative data to help justify a claim. We already talked about that. Remember that what we said in section B, making a graph is not the end of all itself. When you look at a graph, always ask, what do I see? What's the story telling me? What is the story telling me? Okay, shape. Somewhere one of these things it says this: dot plots do retain the original set of data. Go with me? I can tell you exactly how many movies there are if I count them all up. So if I didn't have that, I could use that to get that. Dot plots allow me to do that. There are some graphs I can't go from this to that. Just kind of be aware of that. I think that's something good to be noted. If it says it on one of these slides. Okay, now we're going to talk about the shape. All right, talk about the shape. This is big. You got to know how to talk about a shape. Please remember, you do not talk about shape on categorical data. Starts high and goes low. Well, somebody else's may start low and go high. You can't talk about a shape on categorical data. High, low, and something else, but you don't talk about shape, okay? Numerical, you can, because numerical, it has to go from the low number to the high number. You can't debate that. It has to do it that way. When you describe the shape of a dot plot or another graph of quantitative data, focus on the main features, okay? The main features. You're kind of the overall, right? Look for clear peaks, not little short ones. Not for minor ups and downs. You're not looking at minors up and down. You're just kind of looking at the overall picture, okay? Look for distinct clusters, obvious gaps. Don't look into it really, really, really small and negate it. It's just an overall picture, okay? Does it start low and go high? Does it start low, go high, and then go low? Does it start high, go low? Just overall picture. It's going to somewhat do this the whole way, but I'm just overall picture, okay? Shape. So just kind of look at it through my eyes, the blurry ones, right? Just what does it kind of look like, okay? There's all the lines. Symmetric is the first one we're going to talk about, symmetric. And really, really, really emphasize like the squishy words. Don't say symmetric. Say approximately symmetric, roughly symmetric, somewhat symmetric, kind of symmetric. Put that squishy word in front of it because it's not exactly symmetric. Y'all know what symmetric is. Symmetric, y'all know symmetry. Y'all done some geometry where you have symmetry on one side and you have a mirror image. And that's kind of what we're talking about. We have a mirror image. The left side looks like the right side. The right, oh, they said the other way around, sorry. The right side of the graph contains half the observations, and the largest value is approximately a mirror image, with the largest value, sorry, with a mirror image on the left side. Just roughly symmetric. Roughly symmetric, approximately symmetric, it looks symmetric, somewhat symmetric, but just don't throw one of those squishy words in front of it, okay? I call them squishy words. There's a roughly symmetric graph. It starts low, it goes high, and comes back low. The left side kind of looks like the right side. Kind of looks like the right side. Everybody okay with that one? Skewed left. Don't miss this one. Hey, we always get some kids who do it backwards. Skewed left. The left side of the graph is longer than the right side. That's a picture of skewed left. You're looking at the tail. Okay? The tail is left. Main part of it is to the right. The tail is to the left. Okay? Every year I'll get some kids that get this backwards. Skewed to the left. That's the tail. Okay? I'm going to make it as easy as possible for you. Uh-oh, not with that. What foot is that? Okay? A student sent me that. She said she had a tough time with it and she went to college and took another statistics course. No, no, she had a tough time deciding between left or right. So her teacher said, just look at your feet. That helped her. What? So she, what? It's not her foot, no. Do not get on the internet and search for a foot picture. Don't. I finally had to find a pretty foot picture because, ugh. Okay, so that's the left foot. That's skewed to the left. All right, and that's opposite of the right foot because the right foot's going off the right foot's going. That's where your tail is. So it's your tail. Okay, it's your tail. Every year, out of the students, we'll get a handful of the guys that get that flip flop. Okay, that's too many. One's too many. So skew to the right, skew to the left. Don't rush through it and think about it. Beautiful. Skew to the right. There's your right foot. Skew to the right. Don't be wrong. Be right. Here's skewing downhill. He's skiing downhill. He's going to the left. That one's going to the right. Skiing downhill. I don't care however you got to remember it. Just remember it. I mean, like I said, a couple of kids will do it wrong on the test, and that's too many. Okay. I got two dot plots. Get ready to show you. The dot plots display two different sets of quantitative data. Graph A shows the average number of students per faculty member in the colleges and university for each of the U.S. states and the District of Columbia. So my guess is there's 51 dots up there. Graph B shows the total number of college and university students in 100s of thousands for each U.S. state and the District of Columbia. And that one is that graph. They want us to describe the graph. Approximately symmetric will not give you enough points. The graph of the average number of students per faculty member in colleges and universities is approximately symmetric with a single peak at 14. Do you have to say that? No. Is it right? Yes. Does it describe it a little bit better? Yes. You tell me symmetric just tells me I kind of have mirror image. I don't know if it starts high and goes low and then goes high, or if it has a single peak. So if you say it has a single peak and you tell me where the single peak is, that really describes the graph a little bit better, and you want to try to describe it as best you can without writing a novel. The graph of the total numbers of college and universities is skewed to the right. And if you said with a single peak at 2, you would be wrong, because it's not a single peak at 2, it's a single peak at 200,000, because it's in hundreds of thousands. Just be aware of those type of things. Those are the little things that could ding you because you're not being truthful. It's not at 2, it's at 200,000. Any questions about that? The distribution of the average of students per faculty member in the colleges and universities for each U.S. state and the District of Columbia is roughly symmetric with a single peak at about 14 students. I would not write all that. I think they're a little too serious about putting that in context. But you probably have time to get all that in there. Do I have to mention the single peak? No. The distribution of college universities and student population is U.S. states is strongly skewed to the right. How do you know it's strongly? I don't know. It just looks like it. With a single peak at 100,000. Oh, the single peak's at 100. I said 200. I even lied about that. There are gaps between the 700 and the 1 million, and between the 1.1 and the 1.6, and between the 1.6 and the 2.5. We'll talk about that later. I wouldn't expect you guys to talk about that right now, but that's one of the things that you also need to talk about when you talk about the shape of the distribution. Any questions about the skewed right or symmetric, skewed left? There's one other one. We call it uniform. Uniform is pretty much straight across, pretty close to straight across. Okay. We understand not a single graph is going to be straight across, but it's going to be close. That one's close. All right, it's close. There's a lot of data for each one of them. It's pretty close to being straight across. This is one of those things where I'm going to tell you, I'm going to emphasize again, don't lie. You may say, you know what, this looks a little skewed to the right, and somebody else say, you know, it's a little symmetric. It may be that way. Just don't say it's skewed to the left if it's skewed to the right a little bit. At what point is it? Man, just they don't care. As long as you talk about it and you didn't make up some arbitrary something, they'll give you the points for it. Yippee? Pencils aren't going. I'm going to assume it's time to go. Graphs with a single peak are unimodal. Graphs with two peaks are bimodal. We did talk about the word mode, right? Mean, median, mode. Mode is the most often. So if there's two modes per se, not necessarily two, but two peaks, and that's bimodal. Single peak is unimodal. You don't have to talk about unimodal and bimodal, but boy, if you do, it really emphasizes a lot of things. Okay, that helps you. It boosts your points. It boosts the person that's grading your test, but that's what you want to do. You want to put that person in a good mood. Click. Unimodal, single hump, bimodal, two humps. Pencils. Any questions? I don't want to go too fast, but I don't want to go too slow. I don't want to bore you. I mean, if I bore you, you should get it. But I don't want to do that. That's not the intention. Connor. Yeah. I'll go on this side. I'll leave you alone. That'll make you nervous. A little bit. It's okay. You'll get over it. Click. Describing distributions. When describing a distribution of quantitative variable, don't forget to describe the shape. You have to describe the shape. And that's all we've really talked about right now. Okay? After 1D and 1E, you better talk about the center. Talk about the center. I need the shape. I got to have the center. And then I got to have what they're going to call the variability. Okay? Variability. Spread. How much does it vary? Variability. We'll talk more about it later. Don't worry too much about that word. But those, I'm just trying to, these are things you got to talk about. You got to talk about four things. You got to talk about the shape. You got to talk about the center. You got to talk about the spread or the variability. And then you got to have it in context. And then you also have to talk about anything that looks weird. Outliers, gaps, clusters, anything that looks weird. You just got to talk about it. How do I know if it looks weird? It's going to be obvious. It's obvious. If it's not obvious, then you don't talk about it. Shape, center, spread. I'm going to say it all year long. Shape, center, spread, shape, center, spread, shape, center, spread, shape, center, spread. Actually, I use an acronym for it. CUSS. I don't use shape, center, spread. I cuss. C stands for center. C stands for center. This is not in your notes. You can use it or not, or whatever. U stands for anything that's unusual. Gaps, clusters, outliers. Again, we will talk a lot about this throughout the chapter, not necessarily today. Today's the shape, which is one of the S's, the first S. First S is shape, and then the other one is spread. And then they call spread variability. Variability and spread are the same thing. How much does it vary from the middle, or how much does it vary? More on that on Monday. And always be specific. So that CUS BS. Right, and be specific means in context. in context. There, I put it up there. You got to talk about those. If you leave one of those out, you're missing points. If you leave one of those out, you're missing points. Not all of them have unusual occurrences, but they all have a shape, they all have a center, and they all have a spread. Every one of them. And every one of them have context. So those 4 things you have to talk about. The 5th one, if it's there, you need to talk about it. And if it's not there, you don't have to talk about it. Yay? Boom. Pencils are not going. I have to be over here because I can't read. Tropical cyclones are severe rotating storms that originate in the tropical oceans. One measure of the severity of a tropical storm is the maximum sustained wind speed, which is used to classify storms as tropical depression, tropical storm, hurricane, or major hurricane. There's a lot of tropical storms that don't get talked about. Hurricanes do. Major ones really do. Here's a dot plot of the maximum sustained wind speed in knots for the 193 cyclones in the Atlantic Basin over an 11-year period. 1 knot is a little over 1 mile per hour, just to kind of put things in perspective. Describe the distribution. Well, you don't even see the distribution. There's the distribution. The distribution of the maximum sustained wind speed in knots is skewed to the right, with the center about, don't lie, 45, 46, 42, 40. You're starting to lie at 40 because you got these numbers way out here at 160, right? We could figure out the mean. We could figure out the median. You could figure out the median fairly easily. But right, you're just going to get close. Get close. If you said 60, you're probably okay. If you said probably anything from around 45 to 80, you probably get close. You have to think about those numbers way out there are really pulling that average up. But it's wherever you think the center is, right? If you wanted to use the mode, and you would talk about unimodal with a peak around 40, I don't know, 4. Y'all okay with all that stuff, right? They're going to give you some wiggle room on all that. Just don't say it is 44, approximately 42, looks to be 44, looks to be around 44, squishy words. The minimum is around, good gracious, I don't know what that would be. 30? 35? Don't lie. Maximum 160. That one's easy. Holy cow, 160 miles per hour. Woo! I was in Okinawa one time. We hit one in 120. Woke up the next morning. It was bright and sunny. It was, yeah. We want to get ready to go outside and play. And so where are you going? We want to go play. We were in the eye. We were in the eye for 12 hours. We were in the eye for 12 hours. So then the second half came. Y'all okay with all that stuff? Good? Shape, center, spread, gaps. I don't think there's any gaps. Shape, the distribution. They actually break it up. I don't know. You don't have to break it up into the individual ones, but if you do, it's good. If you want to talk about it all in one paragraph, you can. I don't know how they're going to do all that stuff, but distribution skewed to the right with a peak about 45 knots. There does not appear to be any minor or major gaps. You don't have to say that if it's not there. There does not appear to be any outliers. You don't have to say that if it's not there. The middle value about 55. They said 55. They said the median. They actually calculated it. Whatever. The maximum sustained speed is about from 25 to 160 for these 193 tropical cyclones. Just kind of, a lot of this is a learning process throughout this course. Right now, this is your important one. Right now, that's the most important one. We're just trying to get you to think a little bit on these other ones. Any questions about that? 2 years ago, I had a grade to describe the distribution. And so we looked for the shape, we looked for the center, we looked for the spread. We didn't care if they said anything about outliers or clusters or anything else, as long as they didn't lie. And then we looked for context. And as long as you put the context somewhere, you didn't have to talk about the context on each one of them. You just had to have the context. And that was the 4 things you had to have. If there were 5 things and it wasn't a lie, you were okay. And if there were 6 things and it wasn't a lie, it was okay. But as soon as there was a lie, it dropped you from the 4 to the 3, no matter how many other ones you had. Just kind of keep all that in perspective. Stem and leaf plots. Stem and leaf plots. Okay? So we've talked about dot plots. Now we did the shapes. Now we're going to look at stem and leaf plots, okay? I don't like stem and leaf plots. I think they're really hard to make. They're really hard to decide on how to make them. How about that? But again, you don't have to do that. You just have to know how to read the stupid thing. So you have stems and you have leaves. And the stems are typically on the left-hand side and the leaves are typically on the right-hand side, and they're separated by a bar. So quantitative data, quantitative variable, right, displays each data value separated into 2 parts. A stem, which consists of the leftmost digits. The leftmost digits. The stems have the leftmost digits, and then the leaf consisting of the final digit. Sometimes they remove a final digit. The stems are ordered from least to greatest. Bless. The stems are ordered from least to greatest and arranged in a vertical column. And then the leaves are arranged in increasing order. The leaves are in increasing order. One of those things that the definition is worse than a picture. Click, 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 click. All those underlined things that I underlined. Maybe. Close. Oh, and you got to have a key. You got to have a key. You got to tell me what those mean. Okay, you have to tell me what they mean in the context. Yep. Click. All right, here we go. Mr. Tyson asked the students to use a stopwatch app on their smartphones and collect some data from a single tap. Students were asked to stop the stopwatch at 5 seconds. There were no second chances, and there are the times. So y'all guys can kind of picture if you had your phone out there and you had your stopwatch and you hit start, and you're going to try to stop at exactly 5, it's not easy to do. One student did. Got exactly 5, but others didn't. Some stopped it a little too early, some stopped it a little too late. Good enough with all that? If I'm going to make a stem and leaf plot of that, they're going to look at, what's the smallest time up there? 48? 4.8? There's not a 4.7, is there? Is there a 51? 5.1? Yeah, there's a 51. Is there a 5.2? Yes. 5.3? No. You can't skip numbers down here. Whatever you start with, okay? Then you're going to draw a line. And the first one's 4.87. I'm looking for something smaller. There's a 4.80. So then this is going to be the O. What's the next smallest? 4.8. 5.2. 4.82 looks like. And you're just going to put the 2. Okay? Like that. And then the key, which is the big one. So 5, they chose this one. You can choose any one you want. Doesn't matter which one you did. If I said 491 equals, or 4/1, we're at 4.91 seconds. That's what it means. Because if I just saw 491, I have no idea what that means. Sorry, I put the line in the wrong spot. Dadgummit. Hold on, this is going on the World Wide Web. There. 491. There. You can't skip numbers. You can start with whatever you want to start with. You got to end with whatever you got to end with, but you can't skip. There's the dots. Yay? They're not easy to make. I mean, they're okay if you know where you're supposed to start it and stop it and all that, but the leaves represent the last digit. The stems could represent the other digits. Sometimes they'll round. So rather than saying 4.91, they would round that to 4.9. And so then you would have 4, but all you would have over here was 4 and a 5. If you only had a 4 and a 5 over here, then you're going to have a bunch of leaves. And that's not going to be a very good picture. Stem and leaf plots. Stem, leaf plots. Sometimes they'll do back to back. They'll put a line right here, and then they'll put the other leaves on this side. So they might put the girls' times over here and the boys' times over here. Yeah. Y'all okay with all that? Here's where an uh-oh might happen. Describe that shape. Skewed. Go with me? This is where sometimes it messes up. If you don't like right and left, you can say skewed to the bigger numbers or skewed positively. You can say that if you don't like right and left. But picture this thing coming down this way, and this is my number line, right? This is my smaller number, and this is my bigger number. So we are skewed right. You can't be skewed down. There's no such thing as skewed down or skewed up. Well, you guys are skewed up. I need to get my stick out, except I'm on YouTube and I'm not going to get it out. I'll get it out next time. Woo! All right. Any questions? Y'all happy? Describe the shape of this distribution. Skewed to the right. Are there any outliers? Doesn't look like it. Any gaps? Doesn't look like it. Looks like the center is around, I don't know, 4.92, 4.93, 4.94. I don't know, somewhere in there. We could actually figure it out. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 5, 6, 7. Y'all with me? We could actually figure out what the median is. We could, if I had to. Skew to the right, single peak at 4.99. Click. Yay. Sometimes they'll split the stems. They'll split them. So rather than this be all the 4/8, they'll split them. And they'll put 4/8 and then another 4/8. And then they'll put a 4/9 and another 4/9. And the 4/8, this will be 0 through 4, and this next one will be 5 through 9. The first half and the second half of 4/8, and then the first half of the second half of the 4/9. So 0 through 4, 0, 1, 2, 3, 4. That's 5 digits. And then the 6, 7, 8, 9. 5, 6, 7, 8, 9. There's 5 digits. So that's what a split stem looks like. Gives you just a little bit more information, and now you can see what? A gap. Can't see that gap here. Both of them are still skewed to the right. However, this one's less skewed to the right. This one's actually could be almost symmetric. Close. In fact, I might be better off describing that one symmetric for sure than that one. Yeah, that's where you just don't lie. They probably would accept symmetric, and they might accept very slightly skewed to the right because of that outlier. The outlier wasn't there; it's almost skewed to the left. Okay, everybody happy? Split stems, split stems, split stems, regular stems. These are my stems. These are my leaves. You got to have a key. You got to have a key. If you don't have a key, you have no idea what that data says. No idea. When the data has too many digits, you can get more flexibility by rounding or truncating. This one would not have done me any good around. Oh, this is another one that retains the individual data. So dot plots and stem plots retain the original data. They're the only ones that do. That's important to know because at some point they're going to throw something a little crazy in there and say something a little different. So they retain the original set of data. Okay? I knew it showed it somewhere. Click, click. Histograms. Last one we got to talk about today, ladies and gentlemen. Histograms, okay? We use histograms more than the other two combined. We use histograms a lot because histograms are used for larger sets of data, okay? Histograms look like bar graphs. That's where you have to be a little careful. Bar graphs have a space between them. It's for categorical data. Histograms don't have a space between them. Those bars are connected. It's a graph. Quantitative data displays each interval. It's an interval of values on the horizontal axis as a bar. The height of the bar will show the frequency or the relative frequency. The height of the bar will show the frequency or the relative frequency. Remember, relative frequencies is nothing more than percentages. Yes, no, maybe, what you got? Okay. Histograms, histograms, histograms. There's all of them. Now, histograms is an appropriate scale for large sets of data. Okay, so that's something you got to know there. If you got a large set of data, you want to use a histogram. You don't want to put a dot with a large set. You don't want to draw a histogram with a small set of data. So that's important to know. Which graph would be most appropriate for this? That's a good question. Not make a graph of this. Which graph is important? That's a good question. Mr. Tyson asked the students in one of his classes to record how many U.S. states they have visited. Good question. Driving through the state counted, but flying over them did not. Unless the plane landed in that state, then you could count it. Here are the responses of the 30 students ordered from the fewest to the greatest. That was nice of them to order from the fewest to the greatest. That would be the greatest to the fewest. Oh, that's what it said. Greatest is 31, fewest is 5. I could make a dot plot of this pretty easy also. I don't think it's that difficult to make a dot plot for this. I could make a stem and leaf plot. I would have 0, 1, 2, and 3. Probably would want to split that, but 0, 1, and 2, and 3, draw my line, and then put the leaves. So some of this data is pretty easy to make stem and leaves with. Some of it's pretty easy to make dot plots, but they want me to make a histogram. So to make a histogram, first you want to look at like a frequency chart, okay? And they're going to look at, instead of just actual values, they're going to go from like 0 to 4. Then they're going to go 5 to 9. Now with me, good? Now, oh, I didn't have to go 0 to 4 because there are none from 0 to 4. So then we can go 5 to 9, except they went 5 to less than 8. So they chose it a little bit different. Okay? That makes it a little subjective. Y'all just follow along with me. They went from 0 to 8 instead of me going from 0 to 9. You can go from 0 to 9, it's fine. You just have to go by those 5 digits. They went by 4s. Be careful with the 8. You can't put the 8 on both. So if you're going to go 4, 5, 6, 7, and then the 8, 9, 10, 11. Why they put an 8 here, I don't know. Instead of 8 here, they should have put a 7 here and an 8 here. But it's okay. Not wrong. But understand my histogram now is going to go from 4, 8, 12, 16. Okay? I think it's important to know, though, that the 8s are not in the first bar. The 8s are in the second bar. That you kind of have to think about that. Is 8 included in the first bar or the second bar? Well, if it's included in the first bar, then the 12 is included in the first bar, and the 16 is included in the first bar. If it's included in the second, then the 12 is included in the second, and the 16 is included in the second. And they're both okay. It doesn't matter. Sometimes you don't know. And then you're just going to put little bars up. Click. I got my name right in the middle of it. What questions you got about a histogram? Students get them a little confused because they look like a bar graph. Bar graph goes with categorical data. Let me move all this out of the way. Get out of the way. Bar graphs are categorical. Bar graphs have gaps. Histograms touch because it's continuous. Okay? Yay. Shape. Skew to the right? Probably. Very slightly skew to the right. I'm not too sure if you said symmetrical. If you made smaller gaps, you probably would make it symmetrical. Understand this. This is important to understand. Too big of an interval, I'm going to skyscraper that thing. If I'm going to go from 4 to 10, that's quite a few of them. And then I'm going to go from 11 to 15. And then I've almost got them all. I'm going to too few of them, I'm going to pancake it. So too few, pancake it. Too big, skyscraper it. You want to try to find something that makes it look good. You'd like to have 5 bars at least, but you don't want 20 bars. I mean, they got 1, 2, 3, 4, 5, 6. They got 7. I probably would have had 6 the way that I was doing it because I was getting ready to go by 5s. Questions? Titles, make sure you got labels. You got to have the frequency or the relative frequency, whatever you're putting here. You got to have the title down at the bottom. Just be careful about that stuff. Of course, you're not going to have to make it. Pencils have slowed down. Histograms. We'll use those a whole lot more than we're going to use dot plots or stem and leaf plots. Stem and leaf plots, you might see 1 on the test. Yay? Yay? Everybody happy? Click. Can you use the graph to justify the claim that most of these students have visited fewer than a dozen states? 12 is a dozen. There's 11 of those cats. There's 2 of those cats. That's 12 of those cats. How many students are in the class? 30. 12 over 30 is not 50%. Justify the claim that most of these students have visited fewer than a dozen? Yep. You think it's 13, not 12? Oh, 11 plus 2 is 13. Watch this. There. Bad math. Thank you. First mistake this year. You know how many mistakes I make a year? Connor, how many I make a year? Did you pay any attention last year? I make one mistake a year. That's it. One. I just don't tell you when my year starts. Last year I made a lot. This year so far I've made one. If I make another one, that's when my year starts. Gracious. You know cats have 0 hour? Man. Y'all okay? 13 out of 30 is not the majority. So I don't think most of the students have visited fewer than a dozen. I think most of them have visited more than a dozen. Good? Oh, thank you. Let's see, there would have been 13, which is 43%. That's not majority. Majority is over 50%. Because 0.433 is less than 0.5, we cannot use the claim to use the graph to justify the claim that fewer than majority have visited less than a dozen states. Okay? Beautiful. Histograms do not show individual data. That's where they're going to try to get you. Okay? They're going to ask you, the minimum is 4. No, you don't know. In fact, the minimum is not 4. The minimum is actually 5, but you don't know that from this graph. The maximum is 32. No, the maximum was not 32. But I don't know that unless I have the data. Histograms do not retain the original set of data, and they're going to try to get you on that. They're going to try to talk about the maximum and the minimum or the range. If anybody of y'all have ever done range, or the range is the maximum minus the minimum, they're going to try to tell you that the range is that value, and you don't know what the range is. You don't have any idea what the range is. So be careful with that, okay? We can estimate the center, we can estimate the variability, but we can't know it. This book tends to include the left endpoint of the interval and exclude the right endpoint. Who cares? You'll figure it out. Click. If you're also make a graph, be sure to label and scale your axes. You're not going to be asked to make one, but if you are, make sure you label and scale the axes. Right? Common intervals, label. That's more important than what the graph looks like. Okay. Don't confuse histograms and bar charts. Don't confuse. That's a common uh-oh. I hope you can make and interpret dot plots. I hope that you can describe the shape of a graph somewhat with the SHRP. I hope you can describe the distribution. However, that's not going to be near as big of a deal until after section E. I hope you can make and interpret dot plots. I'm sorry, stem and leaf plots, as well as histograms. Homework should be posted. Vineyard. Marble head of an athlete. Connor, how you doing, bud? You have a good summer? Did you do anything fun? Probably. What's up? How are you? All good? You good? All good?
Yeah, I'm killing you.
Good? You good? Rhino, you good? That,
Be okay if I run this to tech to get my fix it.
you guys good?
Yeah, sir.
Cool, cool.
My sister said that she had to.
Yeah, we're good. Don't say we. You don't know if they're good or not.
Sorry, I just assumed.
Oh, you did? Oh. Are you good? Okay. Miss Akelin, are you good? Okay. Did I teach your brother? And he didn't talk you out of this class? Oh, okay. He passed the exam, I think. Oh, and be in the class? I don't know. I got it saved somewhere, but he didn't work very hard. He is not dumb. He did not work very hard. Yeah, I'd say he's far from dumb, but he's actually pretty sharp. But boy, he's pretty lazy too. That's most guys' issues. Did you know that? Most guys' issues are lazy. How are you? Everything okay? Easy peasy? Thank you for correcting me. You good? Sure.
My Chromebook wouldn't turn on yesterday, and the guy stole it. So I don't know.
You kept it?
Yeah.
What do you think? You okay? You doing good? Okay. How about you three knuckleheads? We're good?
Yeah.
Okay. You already got 100 on the first one?
Yeah, how good was it?
That'd change.
What do you mean that shit?
I said that will change. Oh, yes, ma'am. I recorded.
Oh, you recorded your lesson?
Yes.